section 2.7, which is called derivatives and rates of change. And a lot of this section is review from what we did in section 2.1. We already talked about the rates of change and interpreted them in terms of the slopes of a graph of a function. So remember, part of the review, if we have a graph of a function f, and we take 2 points, A and B, on the graph of f of x, then A has coordinates what? A f of A, and B has coordinates B f of B. Okay. So if we want to talk about the slope of the secant line, which is the line connecting these 2 points, then according to our formula for slope, that's the change in y over the change in x, or the f, so change in y over change in x is f of b minus f of a over b minus a. And in terms of rates of change, what does that represent?
Average rate of change.
This is the average rate of change of the function between the points A and B, so from A to B. So the slope of the secant line, or this difference quotient f of b minus f of a over b minus a, the average rate of change from A to B, these are all equivalent. Okay. These all represent the slope of the secant line. Okay. So that's the average rate of change over an interval, and then we talked about the instantaneous rate of change at a single point. And graphically, what is the instantaneous rate of change? It's the slope of what? The tangent line. So if I draw my function f of x again, and I choose my point A, f of A, and the tangent line, remember, is a line that passes through the point A, f of A, and just touches the graph of the function and points in the direction of the function. So the slope of the tangent line is what we call the slope of the graph, or the slope of the curve y equals f of x at the point A, f of a. So the slope of the tangent line, how do we define that now? Sorry?
Instantaneous rate.
Okay, so in terms of rates of change, this is the instantaneous rate of change of f at A. And to compute, so in practice, when we computed the slope of the tangent line, how do we compute it? We use the limit of what? Almost, right? So what we take is we take the secant line at points B, f of B, and what do we do with the b's?
Move it closer and closer to A.
Move them closer and closer to A. And so we take the limit of the slope of the secant line as B gets closer and closer to A. So the slope of the tangent line is going to be the limit as B gets closer and closer to A, or as B approaches A, of the slope of the secant line, which is f of B minus f of A over B minus A. So the slope of the tangent line is the limit of the slope of the secant line as the point B approaches A, which in terms of rates of change, that's the instantaneous rate of the change of the function at A. So everybody remembers this? This is what we did way back at the beginning of the semester in section 2.1. Okay. Great, so now I want to do the same thing, but I want to introduce some alternate notation here.